For question 1, you're asked a transform from y is equal to root x to y is equal to -1, negative root x plus 3. Let's examine the transformation one by one. So first, from y is equal to root x, you get y is equal to negative root x. Why we are putting negative here? Because we have a negative sign here. So this is a reflection in y-axis. Next, in our transformation, we have x plus 3. So if I add in x, if I add x plus 3, this is a horizontal shift by 3 units to the left. And finally, we want a -1 also. So y is equal to -1, negative root x plus 3. Because we are adding a -1 over here, it means it's a vertical downward shift by 1 unit. Vertically downward shift by 1 unit. So this is the complete transformation. Reflection in the x-axis, then horizontal shift by 3 units to the left. Because it is plus 3, that's why it's a shift in the left. If it was minus, it would be shift to the right. And then finally, because we have y equals to -1, it's a vertically downward shift by 1 unit. So the next part is state the range of f. Range means the values of y which this function fx can take. What are the y values which this function can take? Okay. Now, the domain of the function is x is greater than -3, greater than equal to -3, which means x can be have minimum value -3 and maximum it can go up to infinity, right? So fx is equal to -1. From -1, we are subtracting root x plus 3. If I put this minimum value of x over here, okay, which is -3, what do we get? -1 minus 0, which means even if I put the minimum value of x, fx will at least be -1. If I make x very big, infinity, yeah, then fx will be -1 minus infinity. From infinity, if we are subtracting 1, we still get what? Infinity. Right? So which means you have -1 plus infinity. Anything you add to infinity, it will still be infinity, right? If you add 1 to infinity, you still get infinity, which means this is actually negative infinity. So the minimum value of y that you're getting is negative infinity, and the maximum value of y that you're getting is -1. So what will be the range? Negative infinity to -1. Part 1c, find an expression for f inverse x stating its domain. Now, it's an inverse function. Okay. If fx is the function and its domain is D and range is R, then in the inverse function, the domain will become R and the range will become D. That means the domain of a function is the range of its inverse, and the range of the function is the domain of its inverse. What is the range of fx? Just now we found out the range of fx is -infinity to 1. So the domain of f inverse x is minus infinity to 1, negative 1. The domain of f inverse x is same as the range of fx. Now let's find the expression for f inverse x. Fx is negative 1 negative square root of x plus 3. When we are trying to find the inverse expression for inverse function, we need to rewrite this function making x as the subject. Okay, so there are very clear steps for it. First of all, write fx as y. Y is equal to negative 1 negative root x plus 3. Next is make x as the subject. Make x as the subject. So y plus 1 is equal to negative root x plus 3 and take square on both the sides. So y plus 1 squared is equal to x plus 3. Finally, x is equal to y plus 1 squared minus 3. So we have made x as a subject of the equation. And in the last step, replace x with f inverse x and replace y with x. So I'll replace x with f inverse x and I'll replace y with x. And this is the solution. Next part, find the coordinates of the points where the graph of y is equal to fx and y is equal to f inverse x intersect. A function and its inverse always intersect on the line y equals to x. Just graphically, what it would mean, if I draw the Cartesian plane, and let me just hypothetically draw these two functions. First, I will draw the line y equals to x. And hypothetically, I'm just drawing these two functions. So let's say I have drawn this one function is like this, and this is the inverse function. So the function fx and its inverse f inverse x will always meet on the line where y is equal to x. So that means that if I take the equation of f inverse x is in the previous part we got x plus 1 square minus 3. At the meeting point, the y and x is same. So I can replace this y, which is x plus 1 square minus 3. I can replace this y with x because they are meeting at a point where y is same as the x. So x is equal to x plus 1 square minus 3. X is equal to x square plus 2x plus 1 minus 3. X square plus x minus 2 equals to 0. Which means x minus 2, x plus 1, sorry, x plus 2, x minus 1 equals to 0. That means x is equal to negative 2 or x is equal to 1. So if x is negative 2 and 1, that means there are 2 points where these two graphs meet. If x is negative 2 and positive 1, what's the value of y? So when we solve this, we are getting 2 points of x, negative 2 and 1. But again, think about this. Are both of these answers acceptable or only one answer is acceptable? The answer lies in your part 1b, 1c, the domain of f inverse x. The domain of f inverse x is from negative infinity to negative 1. That means For f inverse x, we can only take those values of x which are less than -1. Yeah, that's why x is equal to 1 is not allowed. So we reject it. This is not allowed. So the only value of x that we can take is x equal to -2. For this value of x, what's the value of y? Y is equal to -2 plus 1 squared minus 3, which is equal to 1 minus 3, and that's -3 or -2. So our point of intersection is -2, -2. -2, -2.